Question 103. In a sample of 50 cars at a local dealership, there are 12 red cars and 10 cars with backup cameras. Of the 12 red cars, 4 have backup cameras. If a car is selected at random from the given sample, what is the probability that both of the following are true? The car is not red and does not have a backup camera. And hopefully when you see this problem, you will not panic. Here's how we might try to begin a problem like this. I would set up a two-way table as shown with the two things we know about it. You either have a camera or not a camera. The car is red or it's not red. Those are the only states of being for those two particular elements. So what did they tell us? There are 50, and we might write in there's a total on the columns, a total on the rows. Out of 50 cars, total, 12 were red. That means the total cars, regardless of cameras or not, was 12. Of the 12 red, we're told 4 have backup cameras. So camera and red is the box right there shown. I can fill that out 4 from the given data. And they also tell us 10 cars have backup cameras. So total cameras, the end of that row, is 10. Now we can begin to fill in our missing elements. We know this camera but not red must be 6 cars, so 4 plus 6 equals 10. We know red but no camera must be 8, so 4 plus 8 equals 12. And we know the missing totals here would also then be 40. 40 plus 10 is 50. 38 for a total that are not red, because 38 plus 12 will equal 50. And then I can lastly fill in that final missing box there. That's 32. 32 plus 8 makes 40, or 6 plus 32 makes 38. Either way you look at it. Okay. Now I have a complete table from which I can answer the question. What is the probability that a car selected at random is both not red and does not have a camera? That's simply that box right there. It's not red and does not have a camera. And of course, if it's probability, that's the number of successes for a condition. We have to divide by the total. Well, there's a total of 50 cars. So that's 50. The correct answer is 16 over 25 when we reduce that fraction. If we wanted to express that as a percent, we would say double 32 and 50 is 64 over 100, or 64%. But notice no answers are in percent terms. They only show the reduced fraction, 16 over 25, and that is your correct answer. The beauty of this approach and setup generally is I could answer most any question they ask at this point. So if they asked a very different question, say, what's the probability of the car either being red or having a camera, but not both? Well, great. I can actually answer that. So that's a camera. It meets the camera condition of the or condition. That's red. That meets the red condition. But we had the extra caveat of not both, so I'd have to eliminate that. The answer for red or camera, but not both, would be 8 plus 6, which would be 14. And if I wanted a probability, I divide that by my total, 50. In other words, this method or setup can be a very useful tool.